Hello everyone, and a very warm welcome back. It's great to see you all. In our last session on K11, we put on our black hats and learned to think like an attacker. We explored the common vulnerabilities in our code and networks and saw just how critical and how challenging it is to protect our data. That session was about understanding the threats. Today, we're going to learn about the fortresses we build to defend against them. That leads us perfectly into our topic. We're moving from the threats to the treasure itself. Our focus today is on K12, the role of data management systems within digital and technology solutions. This knowledge is absolutely fundamental. Every single application you build, every system you analyze, and every network you design is created to serve one primary purpose: to move, process, or protect data. Our purpose in this session is to demystify these systems. We want to understand the digital architecture that organizations use to store, organize, and protect what is arguably their most valuable asset in the 21st century, their data. And to make that practical, our objective is that by the time we finish, you will feel confident enough to identify at least one key data management system in your own workplace, describe its fundamental role, and know exactly how to capture that as a powerful piece of evidence for your portfolio. So, let's begin. Think of data as a company's collective knowledge and memory. Today, we're getting a special pass to go behind the scenes and explore the high-tech libraries and secure bank vaults where that asset is kept. Understanding their role is critical to understanding how the modern digital world actually works. First, let's decode the key term in this KSB, Data Management System, or DMS. A very common mistake people make is to think this is just a technical, fancy term for a database. A database is a critical part of a DMS, but it's only one piece of a much bigger puzzle. Thinking they are the same is like thinking the engine is the entire car. A data management system is the complete ecosystem. It includes the software tools like databases, but just as importantly, it includes the business processes for handling data and the corporate policies that govern how it's used. It's the entire framework an organization uses to manage data from the moment it's created to the moment it's securely deleted. The ultimate role of a DMS is to guarantee three fundamental things about the company's data. First, that it is stored securely, protecting it from unauthorized access and the kinds of vulnerabilities we discussed in K11. Second, that it is organized and consistent, so that we can trust the information and be confident it's accurate and not full of errors or duplications. And third, that it is accessible and reliable, meaning the people and applications that need it to do their jobs can get to it, and the system is available when they need it. I find it helpful to use the analogy of a library's entire back-office operation. The database is just the bookshelf where the books are stored. The data management system is everything else as well. It's the librarian who decides how to organize the books, the card catalog that helps you find them, the security guard at the door, and the rulebook that says who is allowed to borrow which books and for how long. It's the whole system, not just the shelf. So, why do businesses invest so much time, money, and effort into these complex systems? Because this isn't just a technical issue for the IT department, it's a fundamental business requirement. In fact, this directly links back to the very first KSB we have, K1, how organizations gain a competitive advantage. You cannot build a competitive advantage on a foundation of bad data. First and foremost, good data management enables better decision-making. Every time you hear a business leader say they want to be data-driven, what they're really saying is that they need a reliable data management system. Without high-quality, trustworthy data, any analysis is just sophisticated guesswork. Second, it increases efficiency. In many organizations, the same piece of information is stored in 10 different spreadsheets and 5 different systems, and every version is slightly different. This is a recipe for chaos. A good DMS creates what we call a single source of truth, a central, trusted repository that everyone works from. This saves countless hours of confusion, arguments, and rework. Third, it's absolutely essential for security and compliance. As we saw in K11, protecting data is a huge responsibility with serious legal consequences. A DMS provides the technical controls, like encryption and access management, to keep data safe. It's also the primary way a company can prove it is complying with laws like GDPR. And finally, it powers the modern customer experience. Think about the personalized recommendations you get from Netflix or the seamless experience of your mobile banking app. That is only possible because they have incredibly sophisticated systems for managing vast amounts of data about your habits and transactions, allowing them to tailor their service directly to you. Let's zoom in on the heart of any DMS, the database itself. This is the software tool where the data is actually stored. For your role as a technology professional, you need to understand the two main families of databases, because the choice between them is a critical strategic decision. First, and most common, are relational databases. You'll know them by the term SQL, Structured Query Language, which is the language we use to communicate with them. The best way to think of a relational database is as a collection of perfectly organized spreadsheets, which we call tables. Each table has rigid columns and rows, and we use special keys to link related tables together. For example, we might have a customers table and an orders table linked by a customer ID key. These databases are the workhorses of the business world, perfect for structured data that requires high levels of consistency, like financial records or customer information. The second family is non-relational databases, often called NoSQL. If a SQL database is a neat spreadsheet, a NoSQL database is more like a flexible digital filing cabinet. Instead of rigid tables, it stores data in more flexible structures, like documents or key-value pairs. This makes them brilliant for handling huge volumes of data that don't fit neatly into rows and columns, things like all the text from social media posts, the data streaming from thousands of Internet of Things sensors, or logs from a busy website. They are built for flexibility in massive scale. As a professional, your job isn't just to know how they work, but to advise on which is the right tool for the job based on the business's needs. As we've established, a DMS is more than just the database technology. It's a collection of vital business processes that bring the system to life and ensure the data within it is trustworthy and well managed. Let's look at 4 of the most important ones. First, and perhaps most critical for business-facing roles, is data governance. This is the high-level rulebook and the human framework around the data. A data governance program sets out the policies and standards for data across the entire organization. It answers crucial questions like, who is the official owner of the customer data? What are the rules for keeping it accurate? Who is allowed to see it? This is where the business and technology departments meet to agree on the rules. Next is data integration. In any large company, data lives in hundreds of different systems that don't talk to each other. Data integration is the plumbing that brings it all together. The most common process here is called ETL, which stands for extract, transform, and load. We extract the data from all the different sources, we transform it by cleaning it up and getting it into a standard format, and then we load it into a central data warehouse for analysis. A related and very important process is master data management, or MDM. This is the specific discipline of creating one single, authoritative, golden record for the company's most important data entities. For example, it's the process that ensures there is only one perfectly accurate record for each customer, even if the details are stored slightly differently in 10 different systems across the company. This creates that single source of truth we talked about. And of course, underpinning all of this is data security. This isn't just one thing, it's a whole collection of processes. It includes implementing encryption, managing who has access to what data, performing regular audits to check for weaknesses, and planning for how to recover the data in case of a disaster. To fully understand the role of a DMS, it's helpful to think about the journey that a single piece of data goes on, from its birth to its eventual deletion. This is called the data lifecycle, and a good DMS has processes to manage every single stage. It begins with creation or collection. This is the moment data is born. A customer fills in a form on your website, a sensor on a machine takes a reading, an employee saves a new document, new data has been created. Next is storage and processing. The data is saved into a database, where it is protected. Processes like data cleaning, validation, encryption, and regular backups happen at this stage to ensure its integrity and security. Then comes usage and analysis. This is the active life of the data. It's being used by an application to serve a customer, or it's being queried by a data analyst to produce a report that will inform a business decision. Often, the data is then shared or reported. An insight from a report is shared with a manager in a presentation, or customer data is shared securely with a third-party marketing automation system. As data gets older and is used less frequently, it enters the archiving stage. It's no longer needed for day-to-day operations but must be kept for legal, regulatory, or auditing purposes. It's moved from expensive, high-performance databases to cheaper, long-term storage. And finally, every piece of data must reach the destruction stage. When the data is no longer needed and all legal requirements to keep it have passed, it must be securely and permanently deleted. This isn't just good housekeeping. Under laws like GDPR, you are legally required not to hold personal data for longer than necessary. This knowledge is absolutely essential for every single one of you, because in today's world, every role in technology is a data role. Let's make this personal and see how it applies directly to your pathways. For you, then, as our focused specialist, the data analyst, this is your entire universe. The DMS is your primary source of information, your digital library. Understanding the concepts of data governance and master data management tells you which data you can trust. Understanding data integration and ETL processes helps you find and combine the data you need. And a deep knowledge of data quality processes is the key to solving your biggest professional challenge, dealing with messy, unreliable, dirty data. These systems provide the structure you need to thrive. For you, Chloe, our ambitious achiever, the software engineer, you are a primary creator and consumer of the DMS. The applications you build are constantly reading and writing data. Your ability to make a strategic choice between a SQL and a NoSQL database, based on the business requirements, is what will separate you from a junior coder. This knowledge is what will allow you to design systems that are not just functional, but fast, efficient, and can scale to millions of users, the very systems you told us you want to build. And for Maya, our vigilant guardian, the cybersecurity analyst, you are the protector of the data stored in these systems. You cannot protect what you don't understand. You need to know where the sensitive data, the crown jewels, is stored, what security controls are in place, and who has legitimate access, so you can identify and close any vulnerabilities. Understanding the DMS is fundamental to winning the high-stakes strategy game that motivates you. Let's continue, because this knowledge is just as vital for our other pathways. For you, Liam, our resilient engineer, the network engineer, you build the digital highways that all this data travels on. Data is constantly flowing across your network, from a web server to a database, from a database to an analytics platform. Understanding these data flows, knowing which data is most critical, and how much bandwidth it needs, is absolutely essential for designing a network that is both secure and high-performing. For Tom, our methodical interpreter, the business analyst, these concepts are the tools of your trade. You are the one who creates order out of chaos. When stakeholders have vague or conflicting ideas, you use the principles of data governance and master data management to facilitate conversations and create a single, agreed-upon set of data requirements and definitions. This is how you build the clear, unambiguous foundation that every successful project needs. And for you, Aisha, our strategic connector, the IT consultant, your job is to solve business problems with technology. Data is at the heart of that. When you understand the capabilities of a modern DMS, you can confidently advise your clients. You can help them see how they can use their data to make better decisions or improve their customer service. This knowledge allows you to move beyond being a technical supplier and become a trusted strategic advisor, which is your ultimate goal. Okay, let's make this knowledge practical. You are surrounded by data management systems every single day at work, which means you are surrounded by opportunities to gather evidence for your portfolio. Here are 3 simple actions you can take. First, Action 1, identify a system. Your mission is to pick one system that your team uses that stores and manages data. It could be the main customer relationship management (CRM) system, the finance system, or even a well-organized SharePoint site. In your portfolio log, simply write down its name and, in 1 or 2 sentences, describe what its main role is. What kind of data does it look after? This shows you can identify these systems in the wild. Second, Action 2, find a data policy. Go onto your company's intranet or shared drive and find a policy document that talks about data. It might be called the Data Protection Policy, the Information Security Policy, or an Acceptable Use Policy. Find one specific rule in that document. In your log, quote that rule and then, in your own words, explain why you think that rule is important for good data management. This demonstrates your understanding of the policies part of a DMS. Third, Action 3, map a simple data flow. Think of a simple, common process you're involved in. It could be a customer making a purchase, a new employee being onboarded, or a support ticket being logged. On a piece of paper or in a simple drawing tool, try to sketch a simple diagram. Where is that data created? Which system is it stored in? And who uses that data later on? This is a mini data model, and it's a fantastic piece of evidence that shows your analytical skills. Finally, let's talk about your endpoint assessment, specifically your major work-based project. This knowledge about data management systems is absolutely critical for a high-scoring project report. The assessors are looking for more than just a description of what you built. They are looking for evidence of your professional judgment and decision-making. So, the goal is not simply to use a database in your project. It is to justify your choice of database and your overall data management approach. This is how you demonstrate that you are operating at a level 6 standard. In your final project report, you must have a section, perhaps called System Architecture or Design Choices, where you explicitly explain why you made the decisions you did. Don't just say, I used a SQL database. Explain the business or technical reason behind that choice. For example, you might write, a relational database like MySQL was chosen specifically to ensure the transactional integrity required for processing financial data, thereby mitigating the risk of data corruption, which was a key business requirement. Or, a NoSQL document database like MongoDB was selected to provide the necessary flexibility to store varied and unstructured user-generated content, which was a core feature of the application. This shows you're not just a coder, you're a solutions professional who makes strategic decisions. This single act of justification provides powerful evidence not just for K12, but for other KSBs like K2, strategic decision making. Let's do a quick recap. Today, we have opened the doors to the digital library and understood the critical role of data management systems. We've learned that a DMS is far more than just a database. It's the entire ecosystem of tools, processes, and policies that a company uses to manage its most valuable asset. We've seen that this involves understanding different types of databases, key processes like data governance, and the full lifecycle that every piece of data follows from its creation to its destruction. Your mission for this week is to become a data detective. Please, just choose one of the actions from slide 9. Take one small, manageable step to identify and understand the data management systems that are all around you at work. This is how you turn knowledge into skill. This understanding is the perfect setup for our next session on K13, where we will learn the principles of data analysis. Now that we know how data is stored and managed, we're going to learn how to unlock the valuable insights hidden within it. Thank you for your fantastic focus today. You've learned about the systems that are the true foundation of the entire digital world. Well done.